Hello, I'm Frank, and today we're going to talk about a review of radicals, a quick review. Hopefully you've been introduced to radicals, and this review would be good. Quick review, and it would also be very good if you get ready to take an SAT or an ACT, just to review the concepts of radicals. So the first thing I'm going to do is write this radical symbol up there. And this radical symbol is called, some say it's the square root, but really it's the principal square root symbol. Now, a common misconception is, if I were to ask a student a question like this, so I didn't write it because I want to ask you and put you, if I said, what is the square root of 9? And eventually somebody would say 3. I'd say, very good. Why is it 3? And they'd say, well, 3 times 3 is 9. Excellent. Sometimes somebody would say something else. Sometimes they wouldn't. But whether they did or didn't, I would interject this if they did. Well, how about negative 3? And they'd say, yeah, that's it also. I'd say, so you're saying this would be positive 3 and negative 3? And they would, yeah. I'd say, why? Because negative 3 times negative 3 is 9. I'd say, so you think this answer is 3 and negative 3? Yes. So what, do any of you have a calculator? Yes, sir. Type in the square root of 9. And they would say it states 3. But I thought it was a negative 3. It doesn't have that. So what's wrong? You say, is it the calculator? I'd say, no, it's not the calculator. It's because this is called the principal square root. The principal square root means it's got to be a positive number, or 0. It can't be negative. You say, oh. I'd say, so that leads us to a definition that is very tough for students unless they walk through it, as hopefully you were. What do you multiply by itself to get x squared? They would say x. I say, right, x. X times x is x squared. But we got to guarantee x is not negative. We got to guarantee it can't be negative. So how do we guarantee it not to be negative? We put an absolute value in it. So this is something I want you to understand. The principal square root of x squared is the absolute value of x. That gets you away from the negative numbers. I know a lot of questions on standardized tests will try to catch you on this. The principal square root of x squared is the absolute value of x. Okay, now, when we introduce square roots, I'd like to see how far the students can do this in their heads. So I'll list the number n, and then I'll say square n. And most students will say 1 times 1 is 1. Good. 2 times 2 is 4. Good. Likewise, 3 times 3 is 9. And they're pretty good here. They've learned them multiplication tables. 4 times 4. 5 times 5. 6 times 6. 7 times 7, 8 times 8, 9 times 9, and 10 times 10. Now, some students can go on. They can go on 11, 12. Their teachers taught them this. But sooner or later, they're going to stop. They might be able to do 11 and 12, but can they do 13? Can they do 14? Can they do whatever? So I want you to look at this, and I don't know if you've ever recognized this pattern, but it might be something that you think about. How much distance is there between 4 and 1? You say 3. 4 take away 1 is 3. How much distance is there between 4 and 9? 9 take away is 5. How about between 9 and 16? You see something happening? How about 16 and 25? How about 25 and 36? How about 36 and 49? So can you sort of inductively guess what the next one would be? 15. They're going up by 2s, right? So guess what the next one's going to be? 21. You might say, I already knew that. Guess what the next one's going to be? Add that, 144. So my question to you, what would the next one be? What's 13 times 13? Well, you'd say, okay, so the next thing I would add is 25, and what's 25 plus 144? And you'd probably say 169, and that's it. Now, just to know our interest, notice this. What's the difference between 3 and 5? 2. What's the difference between 5 and 7? 2. What's the difference between all these numbers? 2. You'll learn that later on. They're called finite differences. It's pretty interesting. So anyway, if you can get a list going and you don't have a calculator, you can always generate the next one if you can add them numbers. So anyway, so what do we require our students to learn? I expect my Math 1 students, and hopefully you've been through Math 1, to probably know up through the 12s. Years ago, we would require more, but with the use of calculators, why? So you should have a good understanding. Hopefully you do know up to 12 squared. We're going to use these today. So if you're taking notes on this lesson, I would suggest you write these down. So when we get to them latter ones today, we're going to refer back to this list, okay? This list right here. So we're not going to need this anymore. So this will be the list we refer back to. All right, so let's look at our 7 or 8 examples. Really a little bit more than that. What's the principal square root of 49? Suppose I said choices are 7, -7, or 7 and -7. Remember, it's got to be a positive number. It's got to be an absolute value of that number. So this principal square root is just 7. That's it. It's got to be positive. Now, if I said to you, what are the square roots of 49? You could say 7 or -7. But when I put that symbol there, it's got to be the principal, which is the positive. Okay, our second example. What's 3 times the root of 81? Well, you write the number 3. What's the principal square root of 81? If you were to look on that chart, hopefully you know it, it's 9. So what's 3 times 9? And you would say 27. Very good. Now, I'd like to incorporate fractions in my problems. So our third example is -3/4 times the square root of 64. So what is the square root of 64? Principal square root. Look at the list, we put 8. Now, you have 2 options. Do you want to multiply the -3 times the 8 and divide by 4? Some do. But I look at it this way. I like to make the numbers as small as possible. I would prefer you to look at 8 over 4 and leaves you 2. That knocks the numbers down in size, and now multiply the -3 times 2. -6. If I go into a grocery store and I hear people say, well, what's 1/3 of maybe 9? 1/3 of 9. Well, why not just say what's 9 divided by 3? That cuts the number down right away. Okay, our next example is where we get involved in our principal square roots. Is 75 a perfect square? Did we notice 75 on that list? No. It's bigger than 8, because 8 squared is 64, but it's less than 9. 9 squared is 81. So 75 is somewhere in between that. So it's probably 8 point something. Now, to simplify a square root, what you're looking for is there any perfect squares other than 1 which would divide into any? So let's take this off the list. Any number in that array go into 75. Any number in that boxed array go into 75. Well, it'll take you a while. Does 4 go into 75? Does 9 go into 75? Does 16 go into 75? And I know it may take you a while to figure this, but you'll find out that none of them do. But does 25 go into 75? Can't you make 75 cents by 3/4? So it goes into 3 times 25. So what you do is you write the perfect square, 25, and you write the 3 in back up. Because you're multiplying two numbers under square root. 25 times 3 is 75. Okay. Now, what's the principal square root of 25? You say, wait a minute, that was 5. You're right. So this is 5. Once you take the principal square root of that, you get rid of the radical sign, and what follows is the square root of 3. Now, that is finished because there's no perfect squares other than 1 that will divide into 3. So, if you were to take your calculator and type in the square root of 75, and then type in 5 square roots of 3, they would be like the same. So this is called simplifying a square root. Okay, our next example. Now this is an interesting one. If I ask my class, tell me a perfect square to go into 32. Somebody would probably say pretty quick, 4. I say, good. Okay, you ready? And I would pause. Maybe that student might already be writing it down. Okay, let's do it your way. Let's use 4. So I'd say, how many times does 4 go into 32? And somebody would say 8. Very good. Very good. Let's use the same procedure we did. We write this -4. And what's the principal square root of 4? You would say 2 roots of 8. Excellent. Now what's -4 times 2? -8 roots of 8. I say, wait a minute, don't put a box around that. Don't put a box around that yet. Why? We simplified it. Not so quick. Is there any perfect squares that divide into 8? So I say, well, 4 does again. Yeah, 4 does again. So let's do that again. Now all of a sudden this problem's getting longer. Isn't 4 times 2 that 8? Yeah. Then let's say, well, the square root of 4 is again 2. And -8 times 2 would be -16. Let's say, now, are we done? They say, think so? You are, because no perfect squares other than 1. Now usually when I do this, I get done. And sometimes somebody will say, Mr. Ray, that's my name. I figured 16 would go into 32, because 16 is a perfect square. And I say, that's just what I was waiting for, someone to say that. 16. So let's work it your way. So we're going to work it right beside it and look at the difference. So we're working that problem. The student would say 16 times 2. Another student would say, well, why get 16 when we got 4? I said, well, let's give them a chance. What's the square root of 16? They would say 4. And then what's -4 times 4? And all of a sudden, they look at this answer and this answer, and they say, wow, they're the same. They say, well, does this have a moral? You say, well, I don't know, does it? So, well, if you have two perfect squares that you can come up with quick, use the larger one. You should get the answer quicker on most occasions. But some students say, well, you know, why worry about that? If 4 works, I'll just work it out. One of my pet square roots that I'm not putting in here for you today, because I didn't want to get you tangled up with all the different possibilities, but is the square root of 108. I love doing this to my class. There's 3 perfect squares. 4 times 27, 9 times 12. But sometimes a student will say, wait a minute, 36 times 3. And if you use that 36 times 3, you'll get that answer quicker. But who cares? As long as you stick with it and simplify it, right? But sometimes we have time tests. And if you have time tests, you want to do it as quick as possible. So anyway, right now I'd be very happy if you could do it either way and understand it. In time, you'll like that. Pick the higher perfect square. All right. Let's practice our next example. Our next example now is 3/4 times the square root of 80. So, what I would really like to see you do is pause a minute and see which numbers divide into 80 on that list. So, I don't want to sit here and pause the video too long, but I think you'll agree 4 does. Does 9? No. Does 16? You're probably thinking, does it? 16 times 5 is 80. You know, wow, I could use 16. Does 25? I think you're quick there. 25, a quarter doesn't go into 80 cents. Does 36? I think you'll say no. And then 49 is over half of it, so you're done. So, in looking at it, what would be the quickest? 16. But you could use 4. But now that we discovered that if we use the quickest, we will get the answer faster, we start applying it. Okay. So the principal square root of 16 is 4. Now, remember, you can multiply 3 times 4, but you're making the numbers bigger. Why do that? What's 4 divided by 4? You say, that's 1. And what's 3 times 1? And there's your answer to that problem. Okay? All right. Our last 3 examples are just a beginning of adding and subtracting radicals. Our next lesson we'll do multiplication and division. Okay, if I were to ask you to add 3 radical 2, 3 square roots of 2 plus 5 square roots of 2. Think about it. Could you add 3x plus 5x? Could you add 5 apples to 3 apples? You say, yeah, I can add apples to apples. 3 apples and 5 apples would add up to 8 apples. So 3x and 5x would add up to 8x. So 3 roots of 2 plus 5 roots of 2 would add up to 8 roots of 2. So just think of that square root as maybe the apples. They're like terms. 3 radical 2 plus 5 radical 2 is 8 radical 2. Let's look at the next example. Now, you're looking here and you say, hey, one's 12 and one's 27, so I can't add them. Well, you're right in a way. Could you add 3 apples plus 1 banana? No. So you say, I can't add 3x plus y because they're different. So I guess I'm done. Because one's the root of 12 and one's the root of 27. But just a minute. What did we learn previously? You can simplify the root of 12. What's a perfect square into 12? 4. Say, wait a minute, 4 and 3. Okay. But they're not 27. Well, wait a minute. What's a square into 27? You say 9. Both radical 3. What's square root of 4? Principal square root. You say 2. What's principal square root of 9? You say 3. What's 3 times 2? 6. Now, let's go back. Are they like terms? You see the square root of 3 and square root of 3. Can you add 6 apples and 3 apples? You would say, I get 9 apples. Well, we'll call the apple the square root of 3. And there's your answer. Interesting. And then the last one. Okay, we got some fractions. 500 is not the same as 45. So you're wondering, do I simplify? What's a perfect square into 500? Then you can say 4. Some people would say 25 because they know that they can make $5 cash and $5 bill by dividing it into quarters. Take a lot of them, 20 of them, I think. But wait a minute. Doesn't $1 go into $5? So $1 would be 100. So you would say, hey, maybe I can use 100 times 5. Now, 2/3 the root of 45. What's a perfect square in 45? Well, 9. 9 times 5. Root of 5, root of 5. Looks like we might be getting somewhere. What's the square root of 100? You would say 10. What's the square root of 9? You would say 3. What's 10 divided by 5? 2. What's 3 times 2? What's 3 divided by 3? 1. What's 2 times 1? Now they're the same. If you had 6 apples and take away 2 apples, you would have 4 apples. We'll call the square root of 5 the apple. And there you go. So what we did today, hopefully, I hope it didn't go too fast, but I want to keep your attention. We simplified square roots, and I think this is a good review. I know I would encourage any student who was taking an SAT to go back and review their basic radicals, because it's been a while. And it's something you're going to definitely see in your Math 2 and Math 3 classes and beyond. So anyway, the next lesson, we will deal with multiplication and division of radicals, which follows these same policies, same rules. Okay, see you next time.